So for the next couple of lessons, we're going to be talking about the energy that's involved in chemical reactions, also called thermodynamics. And so the first thing that I need to do is introduce the first law of thermodynamics. Now, the first law of thermodynamics states that energy cannot be created or destroyed. So instead, if you lose energy, if energy is lost by a system, meaning by a reaction, then it has to be gained by its surroundings. So for example, if a chemical reaction releases heat, that heat is going to be gained by the surroundings. So you can't just lose energy. So what we're going to be doing in the next couple of lessons is learning a couple of different techniques for calculating the energy involved, or the enthalpy in a reaction. So the first one that we're going to work on in this lesson is using enthalpies of formation. Now, enthalpies of formation are the enthalpy change that's associated with the formation of a compound from its constituent elements. So it's the amount of energy that is released when a specific compound is formed from its elements. And notice I have here enthalpy of formation and then also standard enthalpy of formation. So the only difference between these two is for standard enthalpy of formation, we have standard conditions. Specifically, we're at 1 atmosphere and we're at 25 degrees Celsius. So what we can do is we can use these standard enthalpies of formation to calculate the enthalpy of a reaction. And so what you do is you simply sum the enthalpies of formation of the products, and then you subtract from that the enthalpies of formation of the reactants. And the reason why you do products minus reactants is because in order to form a compound, energy is going to be released, while in order to break that compound down into its constituent elements, that requires energy. And so notice the enthalpy of formation is the energy that's released, so that's why the products, you don't take the negative of it, you just simply add those together. But in order to find the enthalpy of formation of your reactants, you're not actually forming those reactants, you're breaking those reactants down into their constituent elements to then form your products. And so as a result, we have to take the negative of the enthalpy of formation for those, simply because you're not actually forming compounds for that, you're actually breaking compounds down. So it's just going to be the enthalpy of formation of your products, the sum of all of those, minus the enthalpy of formation of your reactants. Now notice N and M there. That N and M represent your coefficients, because you're going to multiply the enthalpy of formation for each of them by the coefficient that is in front of your specific compound or element you're dealing with. Now, I had just said element. Keep in mind that based on the definition of the enthalpy of formation, which is the energy change associated with the formation of a compound, therefore the enthalpy of formation for an element, since it's not forming a compound, its standard enthalpy of formation is going to be equal to 0. So if you have an element in their standard state, meaning, for example, oxygen gas, that's an element. If it's a gas, that's its natural state, therefore that's its standard state, therefore its enthalpy of formation will be 0. So that's important when we're actually doing calculations. So let's look at an example. Here I'm asking for the enthalpy change for this fermentation of glucose here, and I give you the enthalpies of formation for everything that's involved. And so what you need to do is you're going to take the sum of the products, so the enthalpy of formation of the products, and subtract from that the enthalpy of formation of the reactant. So the first product I have is my ethanol. So I'm going to take ethanol, the enthalpy of formation of ethanol, and I'm going to multiply that by its coefficient, which is 2. So I have 2 times negative 277.7 kilojoules. And I'm going to add to that the enthalpy of formation of carbon dioxide. Well, I need to take carbon dioxide's enthalpy of formation and multiply that by 2, because carbon dioxide also has a 2 in front of it. Okay, and then from that, I'm going to subtract the enthalpy of formation of glucose, because remember, enthalpy of formation is the energy that's involved in creating these compounds. While I'm not creating glucose, I'm actually breaking glucose down. So I'm going to subtract the enthalpy of formation of glucose. So I'm going to subtract the negative 1,260 kilojoules, there is no coefficient to multiply, it's just a 1. And so what I have to do is simply take all of this. I've got to add the two enthalpy of formation of my products together, and that'll give me a negative number, and then I'm going to add to that 1,260. And so my enthalpy change for this reaction is going to be negative 82.4 kilojoules. So this is my standard enthalpy change for this reaction.